Hello, welcome to the first session on square and square roots. First of all, we'll take a look into square of a number and the square numbers. We'll discuss them, using or taking the help of few examples. I'll write the question first. The first being the very simple one, we have to check if a number is a perfect square or not. We have here this number 225, which we have to see if it is a, or check if it is a perfect square, and if it is oh sorry, I wrote a wrong spelling. Is 225 a perfect square? Now if we say yes, then we also have to find the number whose square is. If so, we also have to find the number whose square is 225. So let's see. In such questions, first we have to express 225 as a product of their prime factors. For doing so, I'll just take the help of some short rough work. I'll say this is 5, so it is 5 4s are 20, 5 5s 25, and this is 5, and this is 9, and that's giving me 3 3. Thereby I can see the prime factors of the product of prime factors of 225 is 5 into 2 into 3 into 3. So if you see these kind of expressions and can pair each two of the factors in one group, pair or group them at 2 in one group, thereby anything is not left, and for each of them I'm getting this as 1 5 and this being a 3, so it is 15. So 225 is a square number, is a square of 15. Let's take up one more example. I'm not writing the whole question in the next one, simply will be putting up the figure or the number. In the next one we have to check if 63504 is a perfect square or not, and also whose perfect square is, or whose square is 63504. Now let us again do this prime express it as a product of prime factor. I'm just quickly making this table so that it's easy for us quickly. 63504, it's divisible by 2. If I divide it by 2, it will give me 31752. Oh, I said 31752, right? 31752. Again, that is divisible by 2, and that's giving me 15876. I should have actually made them a little broader, never mind. And if I again divide it by 2, I'm getting 2714, 2918, 236, 2816. Again, that's getting divisible by 2, thereby giving me 3 9, having 6 and again 9. This is not anymore divisible by 2, but is 15 and 11, so 36. That's divisible by 3. Again, it's a prime number. I need to make a few of these chairs again. I hope they will fit in my prime factorization kind. This is giving me 1 3 2 3 again. This is again divisible by 3. That's giving me 4 4 1. That's divisible by 3 2. So it's 1 1 7. Let's see if it is divisible anymore. It's again divisible by 3. Or you can put up any other number, like I can see directly that it's divisible by 7. I can take sake of 7, as 7 is also a prime number, so it gives me 21. Again, that's divisible by 7, and that's giving me 3. Let us now try to pair all of them. For every 2 digits, I'll be taking them as one of them. Yeah, there are 2 3s as well, this here and then here. So what I can express it as, how many 2's I got to pair is 2 multiplied by 2 multiplied by 3 multiplied by 7 and another 3. Let's see, 2 2 4 sorry, 4 3 12 12 and 21. I think that's giving me 252. So 63504 is a perfect square of, and that the number is 252. You might come across numbers which are not perfect square. In such case, what would happen is, even if you find this, you express the given number in terms of the product of their prime factors, you will find one or more than one number doesn't have a pair to group themselves, as I have done in these 2 questions. We have paired them, each factors, for every 2 factors we have paired them in one. In a non-perfect number, that you'll come across that there is one or more numbers are left unpaired. We'll take one such example in the next page, wherein I inform you that that's a non-perfect number. Let's see how you come across, or how do you get that one. I got a number which says it is 17640. That's not a perfect square. 17640. Let's see why and how it doesn't leave us with any pairing. I can see it is divisible by 5, which is a prime number. So it's 5, 3 is 15, that's left me with 2, 5, 5 is 25, 1, 5, 2 is 10, 5, 8 is 40. So it is 3, 5, 2, 8. 2 is dividing it, so it is 1, 7, 14, 12, 4. So it is 1764. Then again it is divisible by 2. So it is 2, 8 is 16, again 8 is 16, and then 2, that will again give me a 2. So this is 441. This is divisible by 3. So, and this will give me 3 ones are 3, 1, 3, 4 is 12, 47. Oh, again I got 147, and that's divisible by 7 again. I think we got the same number in the previous question, previous number. That's 7, and it's giving me 21. This will again get divided by 7, which is a prime number again. And I'm left with a 3. Let's start pairing them. I'll be using the same color. This has got a pair. This has also got a pair. Now 3 and 3 given can be paired, but then 5 and 2, they don't have a partners. They don't have a pair wherein we can group them with 2 of the similar factors. So 17640 is not a perfect square. You might come across questions which are not as direct as these ones, wherein you were either supposed to find if they are perfect square or not perfect square. So I'll write one such question. I can take this space up and write the question here. It says, find the smallest number by which, oh, so sorry for the spell mistake, by which 25200 should be divided so that the result is a perfect square. That means it already informs us that 25,200 is not a perfect square. And what do we multiply so that it becomes a perfect square? Now let us first try to understand or find out which of the prime factors doesn't have a pair such that this becomes a non-perfect square. Let's see and start finding out the prime factors of 25200, so that it will help us reach wherein or see or find out why or which factor doesn't have a pair. 25200. See, I can start with either a 2 or a 5. I can see 5 is kind of dividing this 25,200. So it is 5040. Again, I can take a 5. So that's giving me 1008. No more by 5, so I can take up 2. So it's 504. Another 2 again. So it is 2. 2 is 452. That's dividing by 2. So it is, let me extend again. So 252 again divisible by 2 will give us 126. I can directly take 3 as such. 3, 4 and 2 again by 3, so it is 1, 4 and again it is 2 and 7. Here the question said we have to divide so that the number, you also come across questions where it asks you to find a number such that you multiply with the given non-square number so that the answer or the result becomes a perfect square. Now let's see and start pairing them. 5 has got a pair, this 2 has also got a pair, these 2's got themselves a pair, and 3 as well. So 7 is now left without a pair, which we can divide by, so that the quotient whatever we get will be a perfect number. So our answer becomes 7 should be divided from the 7 should be divided, or the number should be divided by 7. Sorry, I'll just say, yeah, you can write, because the question is asking what should be divided to, so 7 can be divided so that we get a number which is a perfect square. This was, the first few very basic things. Now regarding the patterns of square numbers, the properties of square numbers, it is not quite you don't get that in application of any rules or pattern, but then we take up a few questions wherein we get to know about certain patterns of squares numbers, and then we move on to square roots. There are a few numbers given supposedly to you, like the ones I'm writing down on the screen. 1057, and then it is 23453, there is 7928, and then I have got this 2,22,222. These are not perfect squares. Why? With this introduction, we get to know that the natural number which ends in the digit 2, 3, 7, 8 are not perfect squares. So I'll just write down the first one, which you can memorize is any number or natural numbers ending with digits, digits, these ones, the one you can see in the examples, 2, 3, 7 and 9 are not perfect squares. So we henceforth will remember, we come across any numbers ending with the digits, they will not be perfect square. They might just, the next set of, variety of questions under this you will come across, like few numbers or few values are given or the numbers are given. You have to mentally say what would be the unit digit of the square of that given number. That's not quite difficult. Supposedly I have given you 51 or kind of any number. You don't have to actually find out the exact square. It simply will be asking you what will be the unit digit of the squares of these given numbers, like 51 into 51. So the last digit will be, or the unit place digit will be 1 multiplied to 1. So you will be getting the unit digit 1. For 51. For 54, similarly, it will be 4 into 4. So the unit place will have to have 6 of the 16. And 65 into 65, that is 5 in the unit place gives you 25. Again, the unit place will then have a 5, right? Similarly, if suppose you are given some numbers like 213 or 3824 or 9777 or 4002. In such cases, they might ask you if this perfect or if the squares of these numbers will be odd and even. See, it's similar to the application for this one. You first find mentally what will be the unit digit of this square numbers, these squares of these numbers. Like 3 in the unit place, so you will get a 9 in the unit place. That means this will be an odd number. Similarly, 4. So it will 4 is 16. So 6 will be in the unit place. That's an even number. For this, the last digit or the unit digit is 49. So it will get a 9. That's again another odd. For 4002, your unit digit is 2. And if we square it, it will get 4. 4 is an even number. So 4002 square will be an even number. This is the very basic ones. We will move on to few more of such questions on patterns and then take up square root in the next few sessions. Thank you.